In this video, we're going to talk about slope and how to find it. The slope of a non-vertical line passing through 2 points is the ratio of the rise, which we call the change in y, the change in the y coordinates. Sometimes you'll see that represented with a triangle, that's delta y, to the run, or the change in x. So once again, delta x. So you might see this as change in y over change in x, okay? All right, so we want to find the slope, and we're going to do that in 4 ways in this video. We're going to look at a graph, a table, an equation, and 2 points. And then we'll talk about the 4 types of slope at the very end. So example 1, we are presented with 2 graphs. We'll start over here on the left, and what we want to do with the graph is identify 2 points that we can locate and have a nice intersection between our grid lines. So for example, I see a good point right here and a good point right up here. So between any 2 points is a line, so we need 2 points to be able to find the slope. And so now on this graph, we can just use rise over run. So rise would be going up, so we're gonna go from one point to the other, and we're gonna go either up or down, right? So I could start at this point down here. If I do, I'm gonna go up 1, 2, 3, 4, 5, 6 units, right? So my rise is 6. Now my run would be to the next point. So that would be 1, 2, and I went right 2. So up 6 would be a positive 6, right 2 would be a positive 2, and we simplify and say we have a slope of 3, okay? Now also, if I wanted to start, I could start at the top point. I could start at this point right here. If I do that, my rise now will be going down. So I would go down 1, 2, 3, 4, 5, 6, and we would represent that with a negative 6. And my run would be going to the left. So 1, 2, and that would be represented by a negative 2. Well, in that case, you see we would still have negative 6 over negative 2, which would still be a positive 3, okay? So either way you want to go there, you can go up or down, doesn't matter. All right, so let's look at our next graph. Let's find a couple points here. There's a good one there, and here is a good one right here. All right, so I'm gonna start at this point right here, and we're gonna do our rise, which in this case will be going down. So 1, 2, so we went down 2, so that's negative 2. And our run is going right 1, 2, 3, 4. So that would be, right 4 would be a positive 4, and we put that right there. And so now we can simplify, and that would be negative 1/2 as our slope. So notice on the first example, we had a positive slope, and our line was going uphill from left to right. On the example on the right, we have a negative slope, and our line is decreasing or going downhill from left to right. So that's how we find slope from a graph. We represent that as rise over run. All right, so let's look at example 2. We have 3 tables here, and this is actually going to present us with 3 different types of slope. So whenever we look at a table, we want to make sure that we have a constant rate of change, because if we don't, then it's nonlinear. Well, in this case, we're going to see, are these linear? So what we like to do is start at the right side of our table, and notice our output values are on the bottom, our input values are on the top. And just like we did rise over run, we want to do change in y over change in x. This can also be represented as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. When I say sub there, that means a subscript. That just represents point number 1 or point number 2. So what I'm going to do here is I'm going to take this point, and I'm going to subtract to find their differences. So to do that, my change in y would be right here, right? 25 minus 19, and that's going to give me 6. I'm going to do the same thing up here, 10 minus 7, and that's going to give me 3. So far, my change in y is 6, my change in x is 3, and that is equal to 2. But let's just keep going there and see if our rate of change or our slope is constant. So 19 minus 11 is 8, that's different. However, 7 minus 3 is 4. So now in that case, my slope is 8 over 4, which is still 2. Okay, 11 minus 5, 3 minus 0, still a slope of 2. 5 minus 3 is 2. 0 minus negative 1 would be 0 plus 1, which is positive 1. So we still have a slope of 2. 3 minus negative 1 would be 3 plus 1, which is 4. And negative 1 minus negative 3 would be negative 1 plus 3, which would be positive 2. So we do have a constant rate of change, and that rate of change, or that slope, is 2. All right, let's look at the second table. Notice on the bottom, our output is 4 every time. So if we go to subtract down here, we're gonna get 0 every single time, right? 4 minus 4, 4 minus 4, so on and so forth. So my numerator, or my change in y, is going to be 0 every time. So on my change in x, when I do my subtraction here, 9 minus 7 would give us 2, 2, 2, 2, and 2. So we could represent our slope as 0 over 2. But if I think about what that fraction represents 0. So in this case, my slope would be 0. Okay. So we'll look at the end of this video what that line would actually look like. And for the last table, we look at our change in y, 16 minus 12, 12 minus 8, 8 minus 4, 4 minus 0, 0 minus -4. So our change in y is 4. But notice once again, our input values are all the same. So when we go to subtract these, we're gonna get 0 every time, right? So now we have 4 over 0. Well, we can't have a fraction as a denominator of 0. We can't divide by 0. In this case, we would call this undefined. Okay, so that slope is undefined. And once again, we'll see what that line looks like at the end of this video. All right, example 3, we're gonna look at a couple of equations. When we're trying to find the slope from an equation, it's very simple if we can have our equation in slope-intercept form. Slope-intercept form is y equals mx plus b, and the coefficient of x, or the number that is in the place of m right here, is the slope. So on this first example, it's very easy. The slope is 3. That's it, because 3 is in the place of m. Now on the second equation, that's in standard form. So we want to rewrite that in slope-intercept form so that we can easily identify the slope. So let's subtract 4x. So we have 2y is equal to negative 4x plus 8. And then we're going to divide all 3 terms by 2. So we get y is equal to negative 2x plus 4. And now we can easily identify our slope, which is negative 2. So in this case, m is negative 2. And remember, m is our variable that represents slope. Okay. All right, so far we've looked at graphs, we've looked at tables, we've looked at equations. And now lastly, let's find the slope from 2 points. So if we think back to an example we did previously, we used this formula or this equation right here. That's what we're going to use with 2 points. We're going to say slope is equal to the change in y, or y sub 2 minus y sub 1, over x sub 2 minus x sub 1. So we can label our points. We can say this is my first point, x and y coordinate, my second point, x and y coordinate. And now I can just plug those values into my formula. So I can say m is equal to negative 1 minus 2 over 2 minus 0. Okay, so negative 1 minus 2 would be negative 3, and 2 minus 0 would be 2. So my slope here would just be negative 3 over 2, or we could say negative 1.5 for our slope. Okay. All right. And so that leads us to the 4 types of slope that we could get. We could have a positive slope, which we saw at the beginning, where our line rises from left to right. Our number for slope would be a positive number. We could have a negative slope. We would have a negative number for our slope, and that line would fall from left to right. We could have a 0 slope, which is when our numerator is 0. So if we had, for example, 0 over 4, then we would have a 0 slope. That's represented by a horizontal line. And our last type of slope that we could have is an undefined slope, which would be represented by a vertical line. And that's if we had anything with a denominator of 0, okay? And that's the 4 types of slope and how to find slope.